Hey there, welcome to our Chem 286 project Introduction to Local Anesthetics. Let's first begin by asking the question of what is a local anesthetic. While general anesthesia works by using loss of consciousness, local anesthetics work by blocking pain receptors in the body. Now, organic chemists have always been interested in developing new molecules to deal with and avoid pain. In this project, we'll be focusing on three key molecules. We'll be using benzocaine, procaine, and tetracaine as our examples. These three molecules have been very important through history as we try and solve our problem of avoiding pain.
This is a general timeline for the development of local anesthetics, starting with cocaine in 1868. It was found to be very effective for surgery, however, it proved to be highly addictive and toxic. The eucanes, starting in 1887, were synthesized as safer analogs for cocaine and were used in World War I. Benzocaine in 1890 was synthesized during research for an effective substitute for cocaine. However, it is not water soluble, so it is not as potent as cocaine, but it is useful as a topical anesthetic. Procaine was discovered in 1905. It is less potent than other anesthetics, but it is very safe. Tetracaine, synthesized in 1930, was found to be a very effective anesthetic. However, it is toxic in large amounts and dangerous. Lidocaine in 1943 was synthesized by accident when researching a different anesthetic. It is found to be safer than procaine and as long-lasting as tetracaine, so an overall very effective anesthetic. The mepivacaines in 1956, these are amino-amide derivatives and they are found to be potent and long-lasting anesthetics. I will start off with benzocaine. I'll talk about general information of benzocaine, the history, a few different synthesis methods, and its uses as an anesthetic. And here you see the structure of benzocaine. Here you see general information about benzocaine. Its chemical name would be ethyl 4-aminobenzoate. It has an ethyl ester group as well as a primary and non-aliphatic amine, and it has an aromatic ring. Here is a brief history of benzocaine. It was first synthesized by Eduard Ritzert in 1890. He introduced it into the market in 1903 under the name anesthethin. And a bunch of researchers at this time were looking for an anesthetic similar to cocaine with the good effects but not the negative side effects. Benzocaine didn't quite live up to that, but it's still useful as a topical anesthetic. And benzocaine is also useful in studies of nitro group reduction and aryl halide amination and has been studied extensively. There are three main methods to synthesize benzocaine. This includes nitro reduction, amination of aryl halides, and esterification. There are several methods to synthesize benzocaine involving the reduction of the nitro group. These methods can have high yield up to 100%, but reagents can be difficult to work with the product hard to extract using these methods. And the starting materials are common organic compounds, and I will go through some of these reducing methods here. The first synthesis by Dr. Ritzert in 1890 was a nitro-reducing synthesis. He started with 4-nitrobenzoate and used ammonium sulfide as the reducing agent. This is a very efficient synthesis called the one-pot synthesis. It reduces the NO2 group and esterifies the carboxylic acid group at the same time using tin and hydrogen chloride as nitro reducers and ethyl alcohol for esterification. It involves a 1.5 hour reflux and yields 93% according to this study. This is a catalytic hydrogenation synthesis by Adams and Cohen using platinum oxide as a catalyst as well as hydrogen gas under 3 atmospheric pressure. The yield varied from 91% to 100%. This nitro reduction used glycerol instead of hydrogen gas as a catalyst. Glycerol is much safer to work with than hydrogen gas and yields 94%. Next we have synthesis involving aryl halide amination. Nitroreduction was used early in the years of synthesizing benzocaine and amination came later. It involves the conversion of a halide on the aromatic ring to an amine. Amination has better reaction conditions, its reagents are easier to work with, and the yield is also generally high. This is the amination studied by Tao et al. They began with 4-iodobenzoate and used trifluoroacetamide for the nitrogen addition. They obtained a 99% yield. Finally, we have esterification synthesis of benzocaine. In this example, the starting material is 4-aminophenylmethanol, and various reagents are used to esterify the alcohol. Because of its non-aliphatic primary amine, benzocaine is not water-soluble. This limits it to a topical anesthesia. Benzocaine is absorbed through the skin and decreases sodium ion channel permeability, blocking pain signals. An overdose of benzocaine can cause serious conditions and death. Benzocaine is still relevant as a topical local anesthetic. It is used largely for pain relief in the mouth and throat and comes in many different forms including lozenges for sore throats and topical ointment for sore gums.
Okay, let's talk about procaine. First, we'll be talking about its synthesis, and then we'll also be talking about its history throughout time, as well as the uses that we've been using it for. First of all, procaine's an ester of 4-aminobenzoic acid, and it was first discovered in search of a superior local anesthetic without the side effects of cocaine. We'll be going over the synthesis very shortly. The chemical formula is C13H20N2O2, and in comparison to benzocaine, which was previously discussed, procaine has a diethylamine group, which increases its hydrophilicity, which helps its potency, as well as it makes it easier to be an injectable solution. However, this hydrophilicity leads to a direct decrease in the duration of its effect. So now we'll be moving on to the synthesis, and after that we'll be talking about the history as well as the uses of procaine throughout the years. Let's talk about the original synthesis of procaine, first discovered by Albert Einhorn in 1905. He began using his starting material for nitrobenzoyl chloride. Then he ran a esterification reaction involving 2-diethylaminoethanol. This, under very warm conditions for 24 hours, yielded the reaction intermediate nitrocaine. Afterwards, he ran a nitro reduction, reducing the nitro group to an amino group using tin as well as concentrated hydrochloric acid, yielding the desired product procaine. In sum, there's an esterification reaction of the 4-nitrobenzoyl chloride, as well as a nitro reduction, reducing the nitro group of the nitrocaine to an amino group, yielding the desired product procaine. or better yet known as Novocaine. Procaine's discovery in 1905 led it to dominate the local anesthetic market for over 40 years. The effects last between 30 to 60 minutes and begin after only between 5 to 10 minutes. This led it to becoming increasingly popular. It was originally trademarked Novocaine, which is the name that you probably know it by. Today, it isn't as used as much due to lidocaine having a much longer effect time. Once lidocaine was initially discovered in 1942, this led to procaine becoming much less popular due to lidocaine having a time of effect of between 60 to 120 minutes, about double that of procaine. However, procaine is still used in the world of dentistry today. Procaine is used in short dental procedures that last less than 60 minutes, as this fits between its time of effect.
So I'm going to talk about tetracaine. I'm going to start by giving out some general information and history about tetracaine, and then I'm going to continue onto the three ways you can synthesize tetracaine, and then I'm going to finish off by stating its uses and limitations. And we can see the structure of tetracaine at the top right corner of the page. So for the general overview of tetracaine, its chemical name is 4-butyl-amino-benzoic acid, 2-dimethyl-amino ethyl ester. Its molecular formula is C15H24N2O2, and its molecular weight is 264 gram per mole. Tetracaine is a derivative of aminobenzoic acid. It was invented by Otto Islab in 1930, and its structure was inspired from procaine. Tetracaine have a dimethyl amino group, a butyl group, uh, that's attached to an aromatic nitrogen, which is attached to a benzene ring. In the original synthesis, Islip prepared tetracaine in two steps. He started with sodium 4-aminobenzoate, and the first step was the amine alkylation using 1-bromobutane, which gave out the intermediate 4-butyl-aminobenzoic acid. And for the second step, there was an esterification with dimethyl ethanol amine, which gave out the product of tetracaine. The second way to synthesize tetracaine is the catalytic hydrogenation of amides. It's a two-step reaction and it uses a catalyst. The first step is the catalytic hydrogenation of ethyl 4-butyramidobenzoate, and it produces the intermediate ethyl 4-pent 1 into aminobenzoate with an 89% yield. And then for the second step, we take the intermediate and do a transesterification with 2-dimethyl-aminoethanol, and it produces tetracaine with an 85% yield. The third way of synthesizing tetracaine is the continuous flow photoredox amination of aryl halides. It uses nickel salts and ruthenium as catalysts. The starting material is 2-dimethyl-aminoethyl 4-bromobenzoate, and it gives out tetracaine at an 84% yield. The positives of this way of synthesizing is it only takes 10 minutes to prepare, and it uses very small amount of catalysts, and therefore it's economically viable. And usage of tetracaine is it's a longer acting local anesthetic, and its limitation is that it's very toxic. That's all about tetracaine. Thank you for listening.